Radioberry is an open source, full duplex, high frequency software defined radio transceiver designed to operate as a Raspberry Pi hat. Hat means hardware attached on top. Originally developed by PA3GSB, it transforms a standard Raspberry Pi into a highly capable standalone SDR by utilizing the Pi's GPIO pins for power, firmware loading and data transfer. Instead of relying on a traditional mixer and local oscillator, the Radioberry uses direct down conversion for receiving and direct up conversion for transmitting. The board is built around two primary silicon components. One, analog devices AD9866. This is a 12-bit broadband modem mixed signal front-end chip. It handles the actual digital to analog and analog to digital conversions for the RF signals. 2. Intel Cyclone 10LP FPGA. This field programmable gate array, typically the 10CL016 or 10CL025 variants, sits between the AD9866 and the Raspberry Pi. It handles the heavy DSP, that is digital signal processing workload, filtering and decimating the massive flow of RF data before sending it to the Pi. Technical specifications. Frequency range 0 to 30 MHz covers the entire HF spectrum. Maximum bandwidth up to 384 kHz. Receive up to 4 simultaneous RX channels. Transmit 1 transmit channel. Transmit output power 20 milliwatts, that is 13 decibels to the milliwatt, straight from the bare board. Protocol HPSDR, that is High Performance Software Defined Radio Protocol 1, Hermes Lite 2 compatible. Because the bare board only outputs around 20 milliwatts, it requires external filtering like a low pass filter and a linear amplifier to be used as a practical transmitter on the amateur bands. Because the Radioberry uses the open high performance software defined radio protocol, it is compatible with a wide ecosystem of SDR software across different operating systems. Pi HPSDR, a popular choice for running the radio natively directly on the Raspberry Pi. Desktop SDR clients. It works seamlessly over a network with programs like SDR Console v3 and SDSDR and SDR Sharp. Radioberry Juice is a hardware expansion board, an interface board or USB hat that connects a Radioberry SDR module to a computer or alternative single board computer via USB, bypassing the need for a Raspberry Pi. Requires specific Juice firmware or gateware loaded into the FPGA to handle the USB data stream. The Radioberry relies on highly specific GPIO timing for SPI communication with the FPGA. Because of this tight hardware coupling, the project officially targets the Raspberry Pi 4. Recent iterations of the Raspberry Pi, like the Pi 5, introduced significant changes to the underlying GPIO hardware architecture. As a result, standard Radioberry firmware does not work plug and play on the Pi 5, requiring advanced workarounds or alternative data routing methods to function on the newer boards. Adding a linear amplifier and low-pass filter to a Radioberry SDR. To increase the transmit power of your Radioberry for amateur radio use, you need to establish a clear signal chain. Radioberry takes out to linear amplifier to low-pass filter to antenna. Here is the step-by-step breakdown of how to integrate these components effectively. The Radioberry has two SMA connectors on the board, one for receive and one for transmit. Connect a 50 ohm coaxial pigtail from the Radioberry's TX SMA connector to the RF input of your linear amplifier. The bare Radioberry outputs roughly 10 to 20 milliwatts. This is typically enough to drive the input stage of many linear amplifiers to produce a substantial output. Some may need preamplifier circuits. Transmit receive switching, PTT versus RF sensing. When you hit transmit in your SDR software, the amplifier needs to know to switch its relays from bypass receive mode to amplify transmit mode. There are two ways to handle this. Hardware PTT. The Radioberry provides a push-to-talk pin on its I/O connector. This pin goes high or low depending on configuration during transmit. You can wire this to the PTT input of an amplifier. RF sensing carrier operated relay. If you are using an amplifier design like the VU2 EVQ 100 watt linear amplifier, a dedicated hardware PTT line from the Radioberry is not required. These designs feature a built-in carrier operated relay with RF sensing. The moment the Radioberry sends the 20 milliwatt RF signal, the amplifier detects the carrier and automatically switches the relays into transmit mode. VU2 EVQ linear needs about 5 watt input. A linear amplifier will amplify the fundamental frequency of your signal, but it will also generate unwanted harmonics, that is multiples of your operating frequency. The low pass filter must always be placed directly after the linear amplifier's RF output and before the antenna. If you are operating on 80 meter band, for example, your LPF will allow the 3.5 MHz signals to pass through to the antenna while heavily attenuating the 7 MHz, 10.5 MHz, etc. harmonics generated by the MOSFETs. Never transmit through a linear amplifier without an appropriate low-pass filter for your operating band, as it will cause out-of-band interference. Because you are routing the RF output to an amplifier, ensure your SDR software like PyHB-SDR or SDR console has the drive or TX gain settings adjusted properly. Start at a low drive level and slowly increase it while monitoring the amplifier's output to avoid overdriving the MOSFETs. Additionally, ensure your Raspberry drivers and GPIO configurations are specifically set up for your host board, as newer hardware like the Raspberry Pi 5 handles the necessary SPI timings differently than the Pi 4.